Alright, this is part 2 of 1.5. We're going to work on mass percent and empirical molecular formulas. So mass percent's pretty simple. It's like finding how much a percent of an element is in a compound by its mass. So that means you need to find molar mass. So you got to use the periodic table. So here we have ethanol, C2H5OH, things that make it go boom. And you want to find what percent of each element is in the compound. So the first thing is to find the molar mass of ethanol. So 2 carbons, 6 hydrogens, and 1 oxygen gives you a total of 46.07 grams per mole. So for carbon, you would take how much carbon there's total, not just 1 carbon. You have 2 carbons there, so it's 24.02 over the total, which is 46. So it's like kind of finding out how much your grade is in a test. So you take how many you got right over the total, and that gives you the percent. So you get multiplied by 100, and that gives you 52.14% of carbon. So in ethanol, no matter what sample you have, 52% of it by mass is made up of carbon. So for hydrogen, you do the same thing, but you take how much hydrogen you have total, which is 6 grams, over the total, times 100, and that gives you about 13% of hydrogen. And finally, oxygen, you take about 16 grams over the total and multiply by 100 again, and you get 34%. The percents always have to add up to 100, just like your grading test. So that's always a way you can double check. So here's some practice ones. You want to find the percent of each element in copper sulfate. So copper is 63. Sulfur, there's 1, so at 32.065. And for oxygen, there's 4 of them, so you get a total of about 64. So your total mass is about 160 grams per mole, 159.607. So for each element, you should be able to calculate your percent. So if you need to, you want to make sure you be able to get those numbers of copper, sulfur, and oxygen. And make sure you can figure out the calculation. Here, for C2H2, which is acetylene gas or ethylene gas, there's 2 hydrogens and 2 carbons, so a total mass of 26.04 grams per mole. So you can see it's mostly carbon, which makes sense because hydrogen weighs very little. And you should get those percents, about 7.7% for hydrogen and 92.926% for carbon. So again, it has to add up to 100. Alright, so a formula can be either empirical or molecular, or both at the same time, but there's 2 definitions. The empirical formula is its reduced formula, so it's basically taking its whole number ratio of a compound. A molecular formula is its actual real formula that's represented by each element. Sometimes they can be the same, so for example, water, H2O, its molecular formula is an actual compound, H2O, and you can't reduce it anymore because it's a 2 and a 1. But hydrogen peroxide, H2O2, put that on a cut, and you're like, ouch. Anyway, you have reduced formula for HO, or HO. SO2 is, again, a real compound, but it can't be reduced, so its molecular and empirical are the same. The last one, C4H10, butane, is a organic gas, butane lighters, can be reduced to C2H5, which is not an actual compound. Its empirical formula is the reduced formula. Here are some other examples. You get hydrazine, which is a very powerful rocket fuel. Octane, it's also in gasoline, one of the mixtures in gasoline. Benzene, C6H6, and ammonia, which is a cleaning product in Windex. So hydrazine, N2H4, can be reduced. So can octane, so can benzene, but ammonia cannot. It remains NH3 because you can't reduce 1 and 3 any further. Alright, so how do you find the empirical formula? Everything again goes back to moles, so we have to go to moleland. So like everything else, you have to find moles of each element, so you gotta use the molar mass. Then you take the ratio between the elements, so you take the large over the smallest. It's easier than small or large because then you're not working with a decimal. So here's an example. You have an unknown compound of sulfur and oxygen. You have 25 grams of each. Find the empirical formula. So first step is to make sure you get to moles, 25 grams. So you have to use 25 grams of sulfur, use the molar mass of sulfur, cancel out the grams, do a little division, you get 0.780 moles of sulfur. Do the same thing for oxygen. Again, oxygen here is a single element, so you use just O. So you use 15.999 or 16. Do a division, you get 1.56 moles of oxygen. Okay, so that's step 1. Step 2 is do the ratios, large over small. So that means it's going to be oxygen over sulfur, which is 2 to 1. So that means for every 2 oxygens, there's 1 sulfur. So the formula would be SO2. Oxygen always goes at the end of a compound. Here we have another example. This is a more real life example. We'll do this experiment, I think, coming up. So you burn magnesium and oxygen, you get a really bright white flame. Really can't see it. Well, you shouldn't see it because it's blinding. And you make magnesium oxide. So you start with 0.468 grams of magnesium and XX oxygen, so that means you have over amount of oxygen. And it's recorded to be 0.806 grams of magnesium oxide. So we're trying to figure out the empirical formula of magnesium oxide. Okay? So we know how much magnesium, we just don't know how much oxygen. But we can do a little subtraction to find the oxygen from the magnesium oxide. So ultimately we want to find the ratio between magnesium and oxygen, and what should we do first to get the moles of Mg and O2? We got to divide by molar mass, but we need to find out how much oxygen is present. So we have magnesium oxide, we have magnesium, so the difference between the two is oxygen, which is 0.320 grams. Once you find the mass, now we can get the moles of each. In this case, oxygen is by itself, so it is O2, so that's kind of tricky. If it's not by itself, it's just O. So find the moles of magnesium. So you should be able to do this on your own. Molar mass of magnesium and molar mass of O2, so it's going to be about 32 grams. So you should get 0.02 for both moles of magnesium and moles of oxygen. Now we just got to find the ratio. Since they're both the same value, it's going to be 1 to 1. So the formula for magnesium oxide would MgO. So it's a little different type of problem. You have to do a little subtraction, but once you find the grams of both, same steps. Find molar mass to find the moles, and then do the ratio. Alright, example 2. An unknown substance contains sulfur and oxygen. Okay, 40% sulfur and 60% oxygen. Determine the empirical. Whoa, math alert, math alert. So we have percentage, not grams, but it doesn't matter. You use the percent just like you use grams. So just assume you have 100 grams, so whatever percent you have, make it grams. So If you have 40% sulfur, you have 40 grams of sulfur. 60% oxygen, 60 grams of oxygen. So, molar mass, okay, just like the last example, or first example, divide, you get 1.25 moles of sulfur. Here you got grams of oxygen, 60. Again, it's a compound with sulfur, so it's not by itself. So you just use O, so about 16 grams, and you get 3.75 moles. Do large over small, so O over sulfur. Do division, and you get a 3-to-1 ratio. So that means the formula is SO3. All right, homework question. So you want to make sure you write this on a sheet of paper, and you're going to turn this in. You got 85.7% carbon and 14.3% hydrogen. And you want to find the empirical formula for this hydrocarbon, hydrogen and carbon. Again, remember percent, treat it just like grams. You got to find the moles and then do the ratio between large over small. Okay? Good luck. And we're going to move on. All right, molecular formula. So how do we use the empirical to find molecular? So we're going to go with this simple example of a Ritz cracker with cheese in the middle. If you can count, there are 8 crackers in the left side. Each has a piece of, or some cheese in the middle. There's 4 cheeses. 1, 2, 3, 4. So the molecular formula is CR for cracker, 8, CH, 4 for cheese. Each of these can be reduced to 2, well, by 4. 2 crackers and 1 cheese, as you can see here. Okay. Knowing the molar mass of your crackers 2, and knowing that your molar mass of your cheese is 1, what's the molar mass, molecular molar mass? You should get 20. Then what would be the empirical would be 4 times 2 plus 1, and you get 5. Notice the ratio between 20 and 5 is 4. That's the same value that you can reduce the molecular formula. So it's kind of like the same concept of ratios. You have to multiply the empirical 4 times to get to the molecular. So 5 times 4 gives you 20 for the molar mass. Okay, hope that example made sense. If not, I can explain it further tomorrow or when you have a chance. Alright, so let's do an example. So here are the steps. You must find the molar mass of the empirical, okay, because we know how to find the empirical formula from the previous examples. And then you do the ratio again. In this case, instead of moles, it's molar mass. You'll have the given molecular molar mass, and then just the newly found empirical molar mass. Do large over small, and you get how much you need to multiply the empirical by. Alright, so we go back to the same example we found before of sulfur and oxygen. We know the empirical formula is SO2. The molar mass of the compound is 128.12 grams per mole. Determine the molecular formula. So first step is to find the molar mass of our empirical, SO2. So sulfur is 32, oxygen 16. You get 64.06 grams per mole. Now you just do the ratio of large over small. It's always going to be molecular over empirical. So 128 over 64. Simple math gives you 2 to 1. So that means the molecular is twice as much as the empirical. So everything has to get doubled. So the molecular formula would be 2 sulfurs, 4 oxygens, or S2O4. Okay. Here's an example. We have an unknown hydrocarbon, hydrogen and carbon. Its molar mass is 26 grams per mole, and a compound contains 1.85 grams of hydrogen and 22.15 grams of carbon. Determine the molecular and empirical formulas. So this is everything we've done into one problem. So you have to find the empirical. So you need to find the moles of each, not the grams. We have the grams, we gotta get to moles, moland. Choo-choo to moland. So 1.85 grams of hydrogen, molar mass of hydrogen, and you get 1.84 moles of hydrogen. Carbon, 22.15 grams of carbon, 12 grams of carbon. Alright, hold on a sec. Sorry guys. Finishing up. Just got interrupted. Alright, 22.15 grams of carbon divided by 12 grams of carbon. You get 1.84 moles of carbon. So you get the empirical formula is CH, which is great. Now you got to find the molecular formula. So the molar mass of CH will be 1302 grams per mole. So you do the ratio of large over small, 26 divided by 13, which is 2. So now you multiply your empirical by 2, so it should be C2H2. Alright, here's your homework question. Again, see your sheet of paper. You have a compound made up of carbon and hydrogen. This sample contains 79.9% carbon, 20.1% hydrogen. The molar mass of the compound is 30 grams per mole. Determine the molecular formula. So you have to find the empirical first, and then find the molecular.